In what direction we accelerate an object, in that direction only the object will move. So the direction is always same as it is accelerated. Inertia means resistance to change, which means any body that opposes to change its state by itself, we will call it as inertia. What is inertial frame of reference? It is nothing but the frame of reference in which Newton's law is valid. We will call it as inertial frame of reference. Hello everyone, welcome to session 1 of chapter 5, Laws of Motion. This is Swati from Department of Physics, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. So in this chapter, what are the topics we are going to cover? As the name suggests, we are going to study about the laws, the basic laws and applications of the laws regarding motion. But what is a motion? We know motion is nothing but the change in position of an object with respect to time and surroundings. If the object is displacing from one position to other position with respect to time, we will say that the body is under motion. But what are the reasons for this motion? What are the laws that governs this motion? So in the previous unit, we have studied the relation between the velocity and acceleration and the position, the displacement concept. But so far, we have not asked the question, what governs this motion? What is the need? Why does the body keeps on moving from one place to another place? What is the reason for the body to be in a state of rest? What governs the movement of the particle? That is, if a body or the particle has to be in motion continuously, what is required? And the answer for all these questions is a force. What is a force? What is the impact of force on an object when it is at rest or it is in motion? So let us now study more about these things in this chapter. Let us now start with a force. Yes, what is force? It is nothing but an external agency or the external agent when acting on a body changes its state of rest or of uniform motion along a straight line. Which means what? If an object is in rest position, no motion, if we want it to be moved, we have to apply external force. Or if we want to bring the body from a state of motion to a state of rest, we have to apply force. For example, a vehicle which is moving, to bring it to a rest position, we will apply brake, which means we are applying external force to stop a vehicle. Similarly, if a ball is at rest position, if we want it to move, what do? We will kick the ball or we will throw the ball by applying external force. Yes, to change the state of body from the state of rest to motion or to change the state of body from motion to a rest position, we have to apply external force. Yes, it is a vector quantity since it has got both a magnitude and direction, and it is having the direction same as that of acceleration. In what direction we accelerate an object, in that direction only the object will move. So the direction is always same as it is accelerated. So what is the force can be calculated? How it can be calculated? We all know this formula is very familiar to all of us. In vector form, we can represent force with a vector sign which is equal to mass into acceleration, where m is mass of the object and a is acceleration. And the SI unit of force is Newton. So symbolically, we have to represent it with a capital letter. And the dimensional formula for force is mLt raised to minus 2. How to get this? We know F is equal to m into A. The dimensional formula for mass is m since it has no length and time parameters. And now we have acceleration. The dimensional formula for acceleration is L raised to 1 T raised to minus 2. Combining these two, we can write that is m raised to 1 L raised to 1 T raised to minus 2, or we can even write it as mLt raised to minus 2. This is the dimensional formula for force. Now we came to know the basic thing for the object to change its state of rest or uniform motion. An external agency is required, and that is force. This is how we are going to study, or we are going to understand the motion of object and the laws which governs the motion of object. For understanding all these things, the idea of force and few important terms to be needed. And now we are going to study about Aristotle's law, which is also called as Aristotle fallacy. What does it state? What is the statement of Aristotle law? An external force is required to keep a body in motion. It also says that an external force is required to keep a body continuously in motion, and the great Sir Isaac Newton also used Galileo's idea of motion of an object to frame the laws of motion. So, who framed the laws of motion? The laws of motion is framed by a scientist, Newton. So, he actually explained us what are the different laws, a set of laws. These are also called as a physical laws, which helps us in understanding a deep meaning of classical mechanics. So to understand classical mechanics, the laws given by the Newton plays an important role. So he framed the laws of motion by taking an idea of Galileo and this Aristotle, and now we are using the famous 3 laws of Newton in our daily life, and they are familiar to all of us as Newton's laws of motion. So before understanding these 3 laws, what is stated by Newton, let us understand the meaning inertia. What is the meaning of inertia? Inertia means resistance to change, which means any body that opposes to change its state by itself, we will call it as inertia. We all know external agency should be required to change the state of a body. So any body can resist itself to change its state, we will call it as inertia. It is nothing but the property of a body by virtue of which it tries to remain in the same state of rest or uniform motion along a straight line. So here the body will always try to remain in its own state, that is in its state of rest, or if the body is in motion, it will try to be in the same state that is in motion and along a straight line. We will call it as inertia. It's basically a property of body. That body will never try itself to change its state, and this resistance is called as inertia. So now we came to know what is inertia. Let us now understand few important terms to understand the laws of motion. So uniform motion. What is it, uniform motion? When does it occurs? It occurs when an object travels equal distances in equal interval of time. Say for example, if a body travels 5 km in 1 hour, then next 5 km also the body is completing in 1 hour. Next 5 km again the body is taking 1 hour to complete, which means here we can observe the body is taking equal time to complete equal distances. So such kind of motion we call it as uniform motion. When does it happen? It happens when the object is moving with constant velocity. If the velocity varies from point to point, then the uniform motion is not possible, because if the velocity keeps on changing, the body can cover unequal distances in equal interval of time. That is not uniform motion. Uniform motion is nothing but when an object travels equal distances in equal interval of time, when it is traveling with constant velocity, such type of motion we will call it as uniform motion. And what is non-uniform motion? Non-uniform motion occurs when an object travels unequal or the different distances in equal interval of time, then we will say it as a non-uniform motion. So the acceleration of a body moving with uniform velocity will be 0. So if any body moving with uniform velocity, we will say the body is having a 0 acceleration. So all these terms are the concepts which are required to understand the concepts of laws of motion. So next we have a frame of reference. The name itself is giving us an idea to understand what it is. Frame of reference, which means that is a system which is under observation. So, frame of reference is nothing but a frame in which an observer is situated and he makes his observations. We will call it as frame of reference. If an observer is situated somewhere and he is making some observations from that place, we will call it as a frame of reference, which is nothing but the reference frame in which the observations are made. So next we have Newton's laws of motion. I already told you what are these laws. Why the name Newton's laws of motion? The great scientist called Newton helped all of us to understand the laws of science, the secrets of nature. He tried to reveal the secret of nature by his theories and laws. And in these three laws of motion, he gave a precise idea of what is motion, what governs motion, what are the different observations. These set of laws helped us in deriving, in understanding the relationship between the forces that acts on a body, which in turn relates to motion. So these are actually helping us in several various forms from past 3 centuries and many more days to go, and still we are getting knowledge, we are gaining knowledge, and we are applying all these laws in our daily life to understand the laws of nature and secrets behind the surroundings. Yes, let us start with Newton's first law of motion. So what is this first law states that? It is also called as law of inertia. So inertia means we know it's a property of a body which tries to be in the same state, whether it's from state of rest or of uniform motion. So the first law says about inertia. It's also called as laws of inertia. So it states that every body continues to be in a state of rest or uniform motion along a straight line until and unless an external unbalanced force acts on it. Because inertia says that the body which tries to be in the same position. First law is also saying that every body continues to be in a state of rest or of uniform motion, but till when? Until an external force acts on it. An external force acts on it will helps the body to change its state. Say for example, if there is a ball on the floor, it is at rest position. It will be in the rest position until an external force is applied. So when the external force is applied, the ball will roll and it will change its state from rest position to motion. So the first law is saying that every body on the universe will be in a state of rest or uniform motion until and unless an external unbalanced force acts on it. Now we came to know what is Newton's first law. We know what is inertia, what is frame of reference. So the next thing what we are going to study is the relation between all these three, that is inertial frame of reference or non-inertial frame of reference. What is inertial frame of reference? It is nothing but the frame of reference in which Newton's law is valid. We will call it as inertial frame of reference. Any frame, which means the place which we are observing something or the coordinate when we are observing something, we will call it as frame of reference. So in any frame of reference, if the Newton's first law is valid, we will call it as inertial frame of reference. If the Newton's law is not valid in any frame of reference, we will call it as non-inertial frame of reference, where we cannot observe the law of inertia, and hence we call it as by the name non-inertial frame of reference. So let us now understand one more important topic, that is linear momentum. Momentum is always denoted by the letter P. So linear momentum is nothing but the product of the mass of the body and velocity. So to remember this linear momentum, we have to remember one expression, that is P is equal to mv, where m is nothing but the mass of a body and v is nothing but the velocity. Momentum is the product of mass and velocity of a body. How to represent this in a vector form? By drawing arrow mark, that is P equals m into v. Velocity is also a vector quantity and the momentum is also a vector quantity. So the SI unit of linear momentum is kg meter per second. So how it is? Because we know P is nothing but momentum, the product of mass into velocity. Mass SI unit is kg and velocity is meter per second. So the SI unit of momentum is kg meter per second, and the dimensional formula is mlt raised to minus 1. But how it is? We know mass possess only m term and no l and t because it do not possess length and time, and velocity dimensional formula is lt raised to minus 1. Combining these things, we can write the dimensional formula for momentum is mlt raised to minus 1. Now, momentum is a vector quantity. It has the same direction as that of velocity. The body is moving with certain velocity. The direction of momentum is same as that of velocity. Now, mass into velocity we told. How it is useful in understanding momentum in our daily life. For example, if two motor cars of equal mass, the mass are equal, they are moving with different velocities. We know momentum is mass and velocity. So here in this example, we are taking two cars which are moving in a direction with different velocity, but the masses of the cars are same. The effect of collision with the given body will be greater in case of the car which is moving faster, because we know momentum and velocity, they are directly proportional to each other. So the effect of collision with the given body will be greater in the car which is moving very faster. The effect of collision will be higher. So these properties of the moving body which depends on mass and velocity. This is one of the examples to understand the concept called momentum. So now we came to know what is inertia, frame of reference, and the terms related to frame of reference and momentum. Let us now move on to the second law, that is Newton's second law of motion. What does it say? So now we will come to know why have we studied momentum concept. It is nothing but the rate of change of momentum of a body is directly proportional to the applied force. The rate of change of momentum. So momentum is denoted by P. The rate of change means with respect to time it is changing. So dP divided by dt is directly proportional to the applied force. So it can be written as F is proportional to dP by dt, and it is always takes place in the direction of force, in the direction of applied force. So second law of Newton's law of motion can be shortly written as F is proportional to dP divided by dt. Here dP is nothing but the momentum, change in momentum with respect to time, and it is called as rate of change of momentum. It is directly proportional to the force. So this will be in the direction of the applied force. Now we came to know what is Newton's second law. But how to represent 1 Newton, the value of 1 Newton, how to define 1 Newton. So a force is said to be 1 Newton when it is acting on a body of unit mass. We know F is equal to ma. So this value will become 1. When does it become 1? When it is acting on a body of unit mass and unit acceleration in its direction. When the value of m is 1 and a is 1, we can say the force as 1 Newton. So F is equal to 1 N when mass is 1 kg and acceleration is 1 meter per second square. So when the mass and acceleration of an object is unit quantity, we can say that the force is as 1 Newton. So let us now understand one more interesting concept, that is impulsive force. What is impulse? What is impulsive force? It is nothing but the large force acting for short interval of time. For example, to kick a ball for a small interval of time, a large force is applied. That is impulsive force. So it is nothing but a large force acting for a short interval of time. We will call it as impulsive force. What is impulse? Impulse is nothing but the product of force and time for which the force acts is called as impulse, which means it is defined as the product of force and time. What is the SI unit of impulse? The force SI unit is Newton and time SI unit is seconds. So the SI unit of impulse is Newton second. So the impulse force is equal to change in momentum of a body. What is this change in momentum? Change in momentum is nothing but the final momentum minus the initial momentum gives you the change in momentum, and that is nothing but impulse. So it can be written as mv minus mu, because we know momentum is equal to mass into velocity. So here v is the final velocity, u is the initial velocity. Mv minus mu gives us the idea of change in momentum, and change in momentum is nothing but the impulse. So let us now study about the third law of Newton, that is called as Newton's third law of motion. It is very familiar to all of us. We all have heard this lot many times and we know what it is. That is nothing but for every action there is an equal and opposite reaction. So since force is a vector quantity, we can write it as F which is equal to minus FB, because let us take A as a ball, and if this ball is going and hitting a wall called B, what does it do? It will rebounds back, which means it is action and this is reaction. For every action there is an equal and opposite reaction. Since the reaction is opposite, the sign is negative. So we can give n number of examples for this. So let us see a few examples. Swimming. Swimmer is pushed by the water when he pushes the water backwards. If the swimmer tries to push the water backwards, water also pushes him forward in the opposite direction. That is the best example for Newton's third law of motion. And flying of bird. So how does it applicable in the fly of birds? That is, the bird pushes the air downwards by the wings and the air pushes the birds upwards, which means the direction is just opposite, but there is an equal reaction for the action of bird. One more example we can give is a firing of bullet with a gun. When we fire a bullet from a gun, the gun will move backwards and the bullet will move forward, which means here also we are giving action, and when the bullet is moving forward, the gun will come backward. That's a reaction. So when the gun is fired, the bullet is pushed forward and the gun recoils. That is nothing but the recoiling of a gun is an example for Newton's third law of motion. And in case of rocket also, so it pushes out the burnt gases downwards and the rocket is pushed upwards. Again, here we can observe Newton's third law of motion, that is, for every action there is an equal and opposite reaction. So in today's session we have discussed first law, second law and third law of Newton and various terms and factors which are related to these three laws. In the next session, let us understand some more interesting concepts. Until then, keep learning all of you. Thank you.